Thanks for everybody joining. We'll just let a few more folks enter before we get started here with the intro. Feel free to put in some questions. We'll create that long list so we can stump Uma at the end of this with some hard questions. Just teasing. Then we'll definitely continue the conversation in Slack threads the next 2 days if we have more questions to go through. All right, great. And just a plug, if you fill out your profile more, add a picture, engage with the AirMeet platform, you get points, and the top 3 people on the leaderboard will get some Amazon gift cards sent to you. So we have some digital ones that we can send to you. So please, I encourage you, fill out your profile, engage, enter the booths of our sponsors, click on a lot of their resources, demos, some have trials. They're actually kind of fun virtual booths too. So and if you don't like talking to people face to face, you can join in a chat, which is perfect. So let's start out. This is our second keynote of the day. Here we have Mukkara, who's the head of Chaos Engineering at Harness. Prior to this, he was the CEO of Chaos Native, and Harness acquired that. What's great about Uma, as I've gotten to know him over the years, is that he's not just focused on chaos engineering. He's focused on the developer experience, the productivity, and the business. And as you see in this presentation and talking about continuous resilience, this is about enabling the developer, the SRE, everybody to work as a team to build resilience in their software and their systems, right? Just so that we can have a great customer experience. So without further ado, I'll turn it over to Uma, and thank you for being here today.
Thanks, Matt. Hi, everyone. Good afternoon, good evening, late evening for those who are joining out of India and elsewhere. I am Uma Mukkara, head of Chaos Engineering, Harness. Thanks, Matt, for that great intro. I also happen to co-found Litmus Chaos with Karthik and a few other people. We're actively maintaining that project, which is now hosted at CNCF as an incubating project. I actually started Litmus trying to prove that we are doing chaos testing before we ship some product that I was operating, as a CEO of a prior company, right? So what we also have been observing as a success behind Litmus project is a lot of Litmus has been used in QA pipelines and to test Kubernetes resilience, the applications that run on Kubernetes resilience. So that was one of the main reasons why I'm now part of Harness, which is a platform for DevOps, delivering software speed with speed and efficiency. So which brings me to this agenda. I really want to talk about the concept of reliability as it applies to DevOps, and the concept of continuous resilience, a little different than what's traditionally talked about in the chaos engineering space, and also a bit of chaos maturity model, what it really takes to mature a chaos engineering solution, and what are some of the key points. And I've been doing chaos engineering for 6-7 years, working with a lot of open source users and also the enterprise customers. So just really want to talk about some of adoption patterns, how people are using chaos, and what are some of the good recommendations. And I also do want to spend probably about 20 minutes out of the 40 minutes session in showing some of this in action, right? So one service oriented chaos pattern, and also how do you achieve continuous resilience. So with that, let's talk about DevOps, right? So chaos engineering has been talked as mostly as an introduction. Hey, like if you're seeing outages in production, there's revenue loss, so you bring in chaos as a need, right? Chaos engineering. But really, the last 5-6 years, a major transformation has happened because of cloud native transformation, digitalization, and that is driven by speed, the need for the speed. right? And people are moving to cloud native because they need to ship things faster. There are very, very few solutions that are moving to cloud native for other reasons, but it's primarily, to get speed. And when you're shipping things so fast, there's a question of, are you really, really covering the quality, right? So that's another challenge that people are trying to resolve, because they decided to move to cloud native, and what's happening with the quality, and how can I automate things, etc., etc. So when your developers are trying to deal with speed and quality, they are being dragged into many other stuff, and then productivity of developers is coming into a bigger question, right? So in fact, developer productivity in this fast environments is one of the major concern right now, and people are trying to buy them new tools so that they can spend their time on the actual code, not on trying to set up something or debug something, or not working on tech debt, etc., etc. So while a lot of innovation is happening in DevOps, right? So there's a lot of agility happening. Is there enough focus on reliability? That's the big question, right? I would say, people are just, carried away with this agility, with enthusiasm to ship, code fast, etc., etc. So the concerns that really come here is: are you verifying all the paths before you ship? And are you not compromising on quality with such speed? And how much of your developers are spending time in debugging something they should not have debugged at all? And are there any eventual outages that are happening, and developers are coming and spending a lot of time, right? So this is really a kind of an indirect challenge when you don't spend time on or focus on reliability in DevOps. So it's kind of an indirect goal. I would ask the question slightly differently. Do you want to prevent bugs that can potentially cause outages when you ship such stuff into production? Most of the time, the answer is yes. Of course, like we don't want to. We understand stopping a bug right in dev or QA, and we want to do that, right? So the most important learning that I've learned is you need to build the retaining walls in DevOps, or gates in DevOps, so that you are not there may be some reliability bugs, but you're not focusing enough or spending time enough. So that's really the requirement in DevOps. So if you want to retain the reliability in the pipelines and QA, how do you actually do that, right? The questions that usually come here is reliability of what, right? And it's really, when you say it's not really the components, you should still talk about the eventual business services, just like whatever SR is deploy and manage, and against what is another question. So again, faults that can happen. Functional testing has been done nicely, but something can go wrong, and then that can cause an outage. So that's really what I want to measure in DevOps, right? And how do you exactly measure? So you should have enough checks within your DevOps itself to measure how's my entire service doing, even though I'm not deployed at the same scale as what I would deploy in production, right? So even if you want to do the retainment of reliability in DevOps, the answer is try to attack the business services with some faults and measure the steady states. That's really how we do, and that's really what is chaos engineering, right? So chaos engineering is really the measurement of steady state checks while you keep injecting faults. So we started at trying to retain the reliability of DevOps, as we are getting too much agility in DevOps because of the cloud native movement, digitalization, all those reasons. But eventually, the answer is coming to chaos engineering as an answer, right? So, to summarize, you can actually tackle reliability in DevOps with chaos engineering, right? You can increase reliability, you can at least retain and check reliability, And now this is more of a natural choice because things are moving on to cloud native, and their Kubernetes platform itself is causing a lot of expected pod delete kind of failures. And platforms are so agile nowadays that there are issues being caused in terms of microservices going out of band. So when you look at the cost, effort, and time that you're putting into the DevOps for retaining reliability or tackling reliability, chaos engineering is the right approach. So that's what I would summarize. And I don't want to spend a lot of time on talking about what is chaos engineering. A lot of people have talked about here, and now we just crossed the chasm, I would say, from market adoption point. People are aware of what is chaos engineering, right? And that's on the feedback loop really comes in as a way. But generally on the ground, people really stop at trying to set um, you know write experiments, run them, and then get some measurements out of it, right? So it's I've not seen much of the feedback following from ops to this side, the dev side, generally as advocated by chaos engineering. That's because you get busy into something else and you do some game days and you stop it, all that. So on the ground, really chaos engineering is all about measuring what's your resilience, and then your goal is really get some feedback back into the system. And where we are seeing chaos engineering as being practiced more is in financial services for regulatory reasons. And we're also seeing a lot of DR use cases where chaos engineering can be used as a way to prove that you run some DR scenarios. And of course, the well known highly skilled environments, you're losing traffic. And Kubernetes is a natural choice. If your business is running on Kubernetes, you have a natural need to run chaos engineering, right? And the traditional chaos engineering approach, what I've seen really is, it starts, somebody asked in an earlier question, top down, bottoms up. Top down approach is great, but it really starts at, SREs, and, you're burning your fingers and doing it. You need to prove a lot of prove to a lot of people that you need to invest in chaos engineering. But more, natural choice is to really start where code is being churned a lot, right? So try to see the bigger picture, try to pull more people into chaos engineering practices and see how much of chaos coverage is being happening. That's really some of the challenges in this game days approach. So when I say game days approach, I'm talking really about the traditional chaos engineering that generally is seen in the last 10 years or so. So, and also some of the challenges that I would say in implementation of chaos engineering is people really don't understand the bigger picture of how many chaos tests that I need to run, right? So you pick some game days and then you run something, create a zone failure, and then prove that things are happening. But that only proves your reliability against such failures. But failures are small in nature, and they should really feed back into the system to improve the real reliability at the code level, or at the configuration level, or implementation level. So that's really a challenge, right? And there is also a challenge of who creates these chaos experiments, right? So that's another thing that I've seen. People generally talk about tens of chaos experiments. I would say there should be as many test cases as your regular functional tests, or even more, because now you're dealing with a lot of microservices components which are dependent on each other. You're deploying it elsewhere on the cloud platform, so you're looking at hundreds and thousands of chaos tests that you need to be looking at. And also one other challenge that I've seen is what's the ROI? We need to invest in chaos engineering, but how do I tell my management that we're going to get some returns, right? So that's been a challenge that's well talked about, and then that's where it becomes easier to see all these values in DevOps, right? So that the concept of brings us to the concept of continuous resilience. So as you know, we all learned as software developers, engineers, managers, automation is the one that saves our day, usually, right? For productivity and outcomes. That's well known, right? And so now try to apply that automation concept to chaos engineering, right? Can you create chaos experiments automatically? Can you run them automatically? Can you, if something goes, can you create the automation of recovery? So when you think about automation in chaos engineering, you're basically improving resilience continuously, right? So that's where chaos engineering becomes a tool to actually achieve continuous resilience, right? So what is continuous resilience or modern chaos engineering, in my view, is try to verify resilience through automated chaos tests, right? So the important term here is continuous and automation, right? So it's very simple, right? So I'm trying to give a different angle to it, but chaos engineering, to get continuous resilience as an outcome, you have to do it in all places, right? So in dev, QA, and pre-prod, prod. So shift left testing is one, but I would actually say it as shift right, right? So try to do it in QA and then push those tests into pre-prod and prod, right? So you need not put all of this in prod if you are eventually catching most of the stuff in pre-prod and QA, right? So that's really what is chaos continuous resilience. So another important factor here is how do you measure? That's one challenge that I talked about in my earlier slides. So, chaos engineering reliability usually is talked about with the three metrics: mean time to fail, mean time to recover, and mean time to inject, right? So, these are some of the metrics. But if you're talking about improving reliability or retaining reliability in DevOps, there are two new metrics that we need to talk about, right? One is resilience score. Resilience score of what, right? So it could be about a service. Think of your business application is containing, tens and hundreds of microservices that are talking to each other. So you want to talk about resilience score of a chaos experiment against a few services, or a resilience score of a given service when multiple chaos experiments are run on the resources of that service, right? So that's easy to comprehend, right? And a lot of tools out there, either open source or enterprise in nature, we're seeing the concept of resilience score coming out, right? And the bigger question to ask is, are you really running all the required tests that you would want, right? It's like asking the developers, are you doing enough testing? What's your code coverage, right? So try to ask the same question to the developers or QA teams in terms of resilience coverage, right? You cannot obviously ask the SREs, how much of chaos testing have you done in production? That's probably the wrong question, right? So that's where we got into this game day model. But in order to get resilience right into the product, DevOps, you should be asking the developers the same question. What's your resilience question coverage? So how do you define that? It's really about try to think of all the microservices that are talking to each other and figure out the resources within it, and try to find possible faults and do combinations of them, right? You can create hundreds of chaos experiments automatically very easily. And how many are you running them, right, in your pre-prod and QA? And that's your resilience coverage. So I will probably show that in a demo. So now it brings us to just to summarize, chaos in game day versus pipeline is it's really about the adoption barrier. Adoption barrier, when you go to the developers, it becomes very less when you try to bring in automated creation of these chaos experiments. And game days is really, you need to convince so many people and then keep doing it, right? And we're trying to put chaos engineering as a culture into the DevOps rather than as a need for business to retain some reliability through game days, right? So quickly, I just want to talk about the chaos maturity model. I have a lot of slides, but maybe I'll skip some of them. I would like to show the chaos maturity model as four levels, right? So everyone knows about test or start level, and if you ask someone where do you want to go, it's most likely the expert level, where you're talking about trying to randomize failures in production, right? So that's where your expert level. But more practically, you would start within a team and move from, prove that you can do chaos engineering, and then try to do automation of the same things in pipelines, and then try to scale them up to other teams, and then try to randomize both within pre-prod and prod environment. So it's a long process, all right? So chaos engineering, one thing you should take a look at the entire approach as a time-taking process. You could get to level 1 and 2 within few months, right? If you spend time, but getting into level 4 is really time-taking. So let me skip some slides here to save time. So each stage could take 3 to 6 months, and depending on how many teams you have in a company, many teams would be at different levels, right? So give a couple of years at least to reach the maturity of expert in your chaos engineering efforts. So that's really my advice to keep in mind. And in terms of patterns, what I've observed is most of the times people try to do common faults like pod delays, memory hogs, network losses. This is pretty common. And then you try to do incidents. What are the incidents that we have been seeing? Try to reproduce those incidents, which will get you started. This is also not a bad thing to do, but it gives you some good visibility into your how to start off chaos engineering. And where you would actually go convince your team management is if you try to reproduce or practice these chaos tests that are related to expensive outages. So these are sometimes very difficult, but doing that, people try to prove that the ROI is needed or it's driven by business, right? So the other common thing when you have invested in chaos engineering is to take layer by layer. So put infrastructure chaos first, and then go into resources like CPUs and other things, and then try to attack the APIs. You may be consuming the data services, message queues, etc., etc. So you try to go and do some chaos on that, and then try to go and inject some chaos into the application itself. And then finally, your people, how is my team responding, etc., etc. So you try to focus on the high impact chaos infrastructure, and then go all the way up, right? So the most important pattern to me, which we are trying to now advocate through harness chaos engineering, is a service oriented chaos engineering, or the pattern. So, which really means that you are looking at all services together and derive the test cases, and then start with the easier ones and start building the chaos coverage or resilience coverage, and then see you can build confidence of certain resilience coverage into the DevOps itself, right? So the new metrics will start coming in. So this is the service-oriented chaos in Harness. As you can see that you have network maps, which are business applications that contain multiple services, and you start, building resilience cores for each service as well as the chaos or resilience coverage, right? So this is how you would see your services. These are various microservices. What's the resilience score of each service and how much coverage I've done, right? If you try to look at these two things, then everything falls into the place. So let me spend some time in showing a demo of both harness service oriented chaos as well as how do you do chaos in pipelines to build. So let me play this video. Hope this is a simple demo of service-oriented chaos pattern using Harness Chaos Engineering product. What we have here is the ability to go and discover network maps using hotness delegates. And once we discover these network maps, we will have a list of services that are there in a given namespace or a set of namespaces. And you can go and put all of them together, and the relationship will be automatically discovered based on the network flow that's happening among the services. Sometimes you may want to add manual relationships between the services. So you can go and add services that you as you wanted, and then go ahead and add that network map into your control plane. Once you discover and add the services, you can go ahead and target them for chaos. So this is before chaos enabling of the network map. You can see that the discovered services are put together and the relationships are all ready. Now we can go ahead and set them up for chaos. Now that we have discovered few network maps and added them onto our control plane, we can now go ahead and enable chaos on them, or we can configure them as target network maps, where we can run some chaos experiments and then measure the resilience coverage as well as the resilience score. So here are the list of network maps that were added. I will select a boutique app that has 32 services within that network map, and I'll go and try to enable chaos on that, like this. It will automatically go ahead and look for possible experiments that can be created. It will go ahead and configure chaos infrastructure and go ahead and create all the connected chaos experiments, set up the services for monitoring, um, and now your entire network map is chaos enabled. As you can see here, we have the resilience score and the resilience coverage at the target network map level. And right now, there are no chaos experiments that were run. We just enabled the chaos on the target network map. A lot of chaos experiments that were already created for you. Here we have two network maps that are chaos enabled, and some chaos experiments were run. We'll see two specific metrics that are related to resilience. One is chaos coverage or resilience coverage. 23% of the possible experiments were run. 77% of the possible tests were created, but they are not even run yet. Out of whatever were run, you're seeing a resilience of 95%. Here you can see the resilience scores at two different levels. The overall resilience score and resilience coverage at network map level. But when you dig into each service, you can actually see each hexagonal representation here is a service within the network map, and go and see what is the resilience score and resilience coverage. Let's go deep into this, a particular service called Chaos Web Service. And you can see the resilience scores and what are the resources that get out of it, and what are the golden signals for this particular service. Network maps are observed for resilience scores and chaos coverage both at application level as well as at the service level. So let me also next try to give a quick overview of um, the harness chaos resilience. So let me just play this video. This really gives a good overview of how you can take chaos experiments that are built and push them into pipelines, and then protect the resilience within the pipelines. In this demo, we're going to talk about the capabilities of Harness Chaos Engineering and how you can use Harness Chaos Engineering and the CD service together to run chaos experiment pipeline and achieve continuous resilience, as we talked about here. To do this demonstration, I have set up e-commerce website, an application called Online Boutique, which has a set of microservices, such as the front end, cart, checkout, payment service, etc. And I'm using Prometheus metrics and a Grafana dashboard to watch service health. So the dashboards of interest here are the front-end service, there is the card service. As you can see, there is a certain load also that is being run, about 100, 150 operations per second. The front end is hovering around latency of about 100. So right now the application is healthy, and I can go and buy products from the website in place. And I have set up a CD service for one of the card service here, wherein if there is a change to the manifest for the card service, Harness CD will kick in, and it will pick up this manifest and deploy it to the Harness pipeline. So what I'm going to do is I'm going to introduce a change, which introduces certain latency when CPU spikes up. There's this image change, and then watch the image being deployed, the chaos experiments being run to see if everything is intact or we have certain weaknesses when chaos experiments are being run. So let me make that change, then I'll talk about the rest of the setup here. I'm introducing a bad change here, and you'll see that harness pipeline picking it up and deploying to a pipeline. Let's go to the pipeline here. This is the pipeline that is set up for any change. If I go started deploying that particular change, and if I see the configuration of this pipeline itself, you will see after it is rolled out, I've inserted a chaos experiment to be a chaos step, and you can introduce more chaos experiments if you want. And the chaos step is really about picking a readily available chaos experiment from chaos module. These are the modules available to the user, or experiments available to the user in the chaos module. So one of them can be picked up right from the pipeline configurations. So once you pick up a chaos experiment that needs to be run, all you need to configure is the expected resilience score. And if this resilience score is returned by the execution of this chaos experiment is less than that, it results in a failure, which means that a failure strategy will be run, and failure strategy of harness pipelines could be the manual intervention or rollback stage, etc., etc. It's as simple as adding a chaos step through which you can pick up chaos experiments and then run them and configure the pipeline to take an action if the resilience is not up to the mark. So right now we are running a pipeline, and as you can see, the pipeline deployed the change, and it is running chaos experiments. So you can view the chaos experiment execution right from the pipeline. So now it has taken me to the chaos module where it has installed given chaos experiment or set of faults that are there in the experiment, and it has started running on the CPU hub fault. And what this fault is supposed to be doing is it introduces a CPU a hog of 100% on one core for a duration of 60 seconds, and on the container or application with the app label app equal to card service. So this is what is the fault behavior that's supposed to be introduced right now. And while that fault is being executed, you have the capability to perform some steady state checks or what we call as resilience probes. So we have configured three resilience probes here and to check the pod's health as well as service availability, the card service availability, and also the website, the front end latency. So while this chaos is going on, let's go and check how things are going on from the dashboard perspective. So these red lines are nothing but chaos on annotations that we sent to Prometheus metrics, which are being used on the Grafana dashboards to indicate that chaos is in play right now. And as you can see that, this is where he introduced a new change, and the latency continued to be okay around 100. But as soon as we introduced CPU spike on the card service, this is where we introduced a CPU spike, but the latency of the front end service is shooting up. This is clearly an issue which we didn't expect, which probably is not caught in the regular functional testing. But when we are doing the CPU spike testing through chaos experimentation, we are observing this issue on the deployment. So this is a kind of issue that can occur or can be caught only through chaos experimentation. So now the chaos will run for about 60 seconds, and the probes will be run during that time. And once that chaos experimentation is done, you will see some issues being reported. So in this case, the card was not available for a certain time. Also, the latency was not in the range of less than 120 milliseconds. So it's much more than that as we observed here. So what this really means is the resilience score is not greater than 90%. In fact, it is around 33%. Let's look at what happened in the pipeline. So the pipeline executed the chaos experiment, and it resulted in 33% resilience score, and hence the rollback is being pushed here, and rollback is in play. Right. So what it means is that whatever was the image that was there before the pipeline got started is now being replaced. In fact, that's what just happened. And as you can see, as soon as the image is rolled back, whatever is the latency, the steady state conditions, they were retained. So this is what's an example of continuous resilience. Somebody introduced a change, we were able to continuously verify using chaos experiment. We were able to take action in terms of protecting the service resilience. So that's an example of how we can use chaos experiments to deliver continuous resilience. Now going back to a little bit about the capabilities of the chaos module itself. Chaos module primarily contains environments, which are nothing but your Kubernetes or Linux or Windows clusters or any other cloud platform infrastructure that is connected to your work area. And once that is connected, you can run chaos experiments on them. And chaos experiments are nothing but a set of faults that you can put together, either in series or in parallel. And each chaos fault will have parameters such as what's your target application, and what's the behavior of chaos, how often, how many times, and then what are your steady state expectations while that fault is in play. There are multiple types of resilience probes that the product supports. HTTP probe or Kubernetes or prompt QLs you can write, or you can write a total custom probe called command probe, which is nothing but your own program. You can call some SLO checks or any other service checks that you want to provision at that time. So that's what is an experiment, and you can schedule them, periodically, or you can run it in pipelines as needed, or you can trigger them based on change such as GitOps. Right? So it also has a library of chaos faults, and we deliver them through chaos hubs. So Harness has by default an enterprise chaos hub. You can see that it's got around 107 types of faults for various different areas. For example, we have 32 chaos faults that cover different chaos faults for Kubernetes. Similarly, there's a full spectrum of chaos faults for VMware, and for AWS, we have EC2, CS, and other faults even for serverless. And it also covers Azure GCP. There are some Spring Boot app level chaos as well. So these are chaos faults, and there are chaos templates also, which can be directly run from the hub itself. And chaos hubs, this is an enterprise chaos hub, and add your own chaos hub and maintain your own experiments in chaos hub, and others can you connect to that chaos hub and run them from there. For example, this particular chaos experiment that I ran can add to a given hub, right? And then once it is up, whoever is connected to the hub have access to this chaos experiment. So that's a overview of Honest Chaos Engineering and how you can use Honest CD and Honest Chaos Engineering together to deliver continuous resilience by executing chaos experiments in the pipeline. So hopefully that was interesting. So I really want to summarize. We are almost on time. So just want to summarize my talk here as think of continuous building of activity around resilience is a must. Unless you automate this test in your DevOps, there is no easy way to build structural resilience into your services, right? And also start small and try to bring in developers, because those are your experiment writers, right? And once you get that little challenge resolved, you start actually increasing the chaos coverage, and then you can start sharing those chaos hubs, your own chaos hubs with experiments to the other teams, and then it will start trickling down to the other teams. So we do have a workshop right after this keynote, where you can actually get your hands on. We'll provide you the sandbox environments. What are the demo that I just showed here? A part of it you can do, and then later I think our team is trying to get you some offline workshops as well if needed. So with that, I'd like to take some questions. Matt, looks like there are plenty of them. I don't know how much time we have.
Yeah, no, thanks, Uma. Great presentation. So we have a bunch of questions. I put them all in Slack too, so we can definitely carry that conversation forward there. But the top voted One I'll put on stage, and then I'll actually just invite this user to the stage if they want. But Uma will talk while the person wants to join or not. But basically, this person's asking just about like, are we seeing this in any compliance or framework standards like ISO or BS, 2599 or, ATSM or NIST?
Yeah, no, this is a great question. We are really at the beginning of a chaos engineering journey as it applies to the whole industry, right? So we are seeing chaos engineering is being asked as a regulatory requirement in financial institutions, right? And the feds are, also are asking, have you done chaos engineering? Soon there will be standards or at least best practices of how to use chaos engineering for this business continuity, but there are no real standards for such complaints right now. But I foresee them coming up in the next few years. Great question, though.
Yep, great question. And if you come to the chaos panel tomorrow, I have some questions that relate to this as well that I want to dig into, because I think as a community we can drive some of this urgency and priority to make changes in ISO or whatnot. All right, next question. I can invite John Cash on if he's able to join too, but could you highlight some popular recovery measures in today's chaos engineering practice?
Yeah. So recovery is a great question. I talked about automating the recovery processes as well. So depending on which environment that you're running chaos, the popular, if you talk about Kubernetes, some of this chaos will result in not recovering from such chaos because either recovery time modes are not good enough, or your auto scales are not covered, configured properly, right? Or your node scalers, node selectors are not configured properly. So usually, in such cases, the recovery is to introduce more nodes automatically and kickstart any other standard recovery mechanisms. The unpopular or very effective is to kickstart the DR as well as a recovery mechanism, right? Depending on your business service. If you're in a financial services mode, it automatically should, if the blast radius is out of control and if your resilience score is not matching, you have the need to recover automatically, especially if you're doing it in prod, right? And that's a popular use case as well, right? You need to prove that the services are recovered through DR, so you use chaos engineering to prove that as well.
Awesome. Yeah, chaos engineering has changed so much since I've started, and now it's even safer. So I love that recovery strategy. Then just maybe one last question here. It looks like we have a bunch of Fed people on the phone too. They're curious what you're seeing, in the federal government for chaos engineering, and specifically, is the harness product Fed compliant, or do you have any recommendations there to start?
Yeah, definitely. One thing that is happening with Fed services are they're moving to Kubernetes, right? I mean, we see a lot of buzz in the area of what can I do in the Fed areas I've been maintaining. I want to move to Kubernetes, so the Iron Bank image certification becomes mandatory. So Harness is releasing module by module. So in fact, Harness is Fed compliant as of now, and Chaos Engineering is one module. So in about a quarter, we'll be Iron Bank certified for Fed, and you can deploy. So we will be one of the very few vendors who have that end-to-end functionality with Fed compliance.
All right, great. Well, you know what? There's so many questions left over that are great, and we could probably talk for another hour, but I'm going to put those in Slack so we can continue the conversation. And then we have 2 workshops that you can roll into after this keynote here. So one is with Harness, just to learn how to use the Harness Chaos Engineering product and run some experiments. We get certified if you want to. We're excited about that. And then Blameless has another one. So it's how to create a streamlined incident management runbook. So we got 2 tracks there that you can join, hop in and out if you need to, but looking forward to seeing you all there. And again, Uma, thanks so much for the presentation and demo. It's been great. Thank you everybody for attending.
Thanks, everyone. I'll look forward to answering some of these questions in Slack.
Great. Thanks all.